Okay, welcome back to week 6 of the Cube for All. Thank you so much for all your support all this long, and we are straight into the week 6. And today it's going to be another interesting topic. While running stateful applications on on Kubernetes itself is a highly debatable topic. Today we are going to talk about running a distributed database on a distributed environment, right? So we are going to see how to run MongoDB on Kubernetes and some of the strategies around its replication, what kind of configurations you need to add and maintain across shard modes, and some of the access methods through which you can access the MongoDB, and how do you launch your applications in different access modes and launch modes, and also see how you can scale, partition, and update your MongoDBs on Kubernetes, right? So let's jump into each one of these, MongoDB replication and sharded modes. What are their differences, and how do you configure, and what's the architecture overall? Okay, so MongoDB supports two different ways in which you can replicate. So one is the plain distributed or the plain replication mode, and the other is called the sharded mode, right? So the replication is used for high availability. So when you have multiple, you can bring up multiple replicas, and you replicate the same data across multiple nodes, and you call them as replicas here, right? And if one of the nodes go down, you still have the data in your other replicas. So this is for high availability, whereas the sharded is for horizontal scaling. So your data keeps growing, and you have to grow your the scale of your database. So in which case you have a horizontal scaling. You can also have a vertical scaling where you can increase the CPU and memory or the disk space, but if you are running on a limited infrastructure, or rather on certain cloud service providers, they don't have they always have an upper limit of how much of a CPU or a memory or a disk can be added. All right, so on a cloud based environment, you may want to scale horizontally by adding more smaller nodes, and then you keep growing as you need, right? So this is supported through MongoDB in the form of sharded mode. And what happens here is that MongoDB's data gets, or rather, we call them as collections, right? Which are very synonymous to tables in RDBMS, right? So you have these collections partitioned into small chunks called shards, and these shards are distributed across multiple nodes. Here, you don't have high availability, so even if a particular shard fails, you are losing a part of your data, not completely, but a part of your data. However, since all the read-write requests are distributed across these shards, you have a better performance and better scalability also. So let's take a look at each one of these modes, and then see how they are configured and what are their services or architecture overall. It's very important for us to understand the architecture before we go and deploy such services on Kubernetes. Okay, so let's go to the distributed mode. As I said, this is a replication of a high availability. You have a couple of primary and secondary nodes. So we call them as replicas. So on the right hand side, you see that there is an application, and you can have, say, MongoDB 0 and MongoDB 1. So 0 is your primary, and MongoDB 1 is your secondary. And your applications can do all your read-write operations only to the primary. So you can only write to primary, but you can read from either primary or the secondary. And as and when any write operation happens, all these transactions are captured in the form of oplog transaction logs. All right. So and once all the write operations complete, in the data is all the right data is applied, or the transaction logs are applied on your secondary nodes. All right, so the data is completely replicated from your primary to your secondary. Now this is the architecture at a high level. And if suppose the primary goes down, then based on the remaining number of replicas or the nodes, MongoDB will try to elect one of those nodes as the primary. because you need somebody to handle all the write requests, right? So if you have a two node cluster, one being the primary, another being the secondary, and if the primary goes down, so now you need to elect between certain nodes to decide whether who has to become the primary. Now, if you have a two node cluster, and if the primary goes down, there is only one node which is left out, which is your secondary node. So you cannot elect just with one node, right? So you need one more node to elect between these two nodes. So you can bring up something called as an arbiter, which is specifically for the purpose of voting. And in such scenarios, when you have a tie, an arbiter can mediate and help you in choosing the primary node. And arbiter is much like your replica, but it does not hold any data, right? So if you see that there are no persistent volumes attached to arbiter, whereas for your primary and your secondary, you have a persistent volume attached. Now we have I'm going to show you with respect to the Bitnami template. So you have a configuration or an environment variable which decides what is the mode that you can use. So if the replica mode is set to primary or secondary, based on this environment variable, your deployment will decide whether it has to bring up in the primary or secondary replica mode, right? So this is a very straightforward distribution mode. Let's go to the sharded mode, right? So the sharded mode is helpful for high availability and scaling your database horizontally. Now there are additional components here. So if you see on the right hand side again, you have your application, but your application no longer talks to your MongoDB services directly. It has to always connect to MongoS, which is a routing service which routes all your read-write requests to different shards, right? So you can do both read writes across all the shards. So since these read writes are distributed, it also helps in improving the performance, right? So let's take this example, right? So you have a shard server primary and shard server secondary, and it has a couple of shards. So a shard is a collection partitioned and distributed, right? So you have a few on the shard primary and few on the shard secondary, right? Now you can also have a shard arbiter, which does not have a persistent volume, very similar to the previous the replication mode. In addition, you also have a config server, and that also can run in the replication mode. So you can have a config server primary and a config server secondary. And the purpose of this config server is to maintain the metadata of the cluster and all the configs, right? So in a production mode across both these, shard and replication mode, it's always a recommended option to bring up all these replicas with three node cluster, right? Even across configs also, it's better to have one primary and two secondary, and same way for your shards or your other replicas as well. Now we have two environment variables that aid you in this selection. One is your sharding mode, which tells you whether it is MongoS or config server or your shard server. And the other one is your replication mode, just like the previous one. You say whether it is secondary, primary, secondary, or the arbiter. So the difference here is that in the first case, the template already has an arbiter container by default, so you don't have to set the replication mode explicitly. Whereas in the second case, in the sharded mode, the same, the Docker image is being used, and you can in fact bring up arbiter on a dynamic basis, right? The first case, it is static and it is pretty much there. So I'm going to show you an example of that and how it is, configured in the marketplace within gopaddle, and I will show you how these environment variables can be tweaked. Okay, another information is, like you see, even config servers are stateful, and you have persistent volumes attached, right? So let's move on to the different types of access modes. Now that you're running a stateful application, there are different ways in which you can access these stateful services within your application, right? So Kubernetes itself supports cluster IP, which is primarily used for inter-pod communication, so between the pods, and it has an internal IP address. And you can use either this IP address or your service name if you're actually trying to access it within the same namespace, Or you can use a fully qualified DNS domain name, like your service name followed by your namespace followed by service cluster local, right? If you are running it as a headless, okay, so what is headless? So in case of cluster IP, there is some sort of a load balancing. So you have a Kubernetes service which load balances your request across the different pods. Whereas in case of headless, the request goes directly into your pods. Because, as I said, like in stateful, the configurations are very different. There is a data attached to your pod. So sometimes you may not want that to be load balanced, right? You want that particular read write request to go to a specific pod. So you have to bring up your stateful applications in a headless mode, right? And it does not have an IP. So for instance, you can, in case of gopaddle, what we do is if you choose your stateful application to be accessed as a headless, then we bring up a service with the postfix as the service name followed by hyphen and headless. So you can access the service using my service headless within the same namespace, or you can use the complete fully qualified domain name if you are trying to access it outside your namespace, right? In the last option is if you want to expose your service externally, and you don't do this for a database, you want to keep that really secure. So in this, like most often you will resort to headless or to cluster IP. But if you have an application that has to be exposed externally, so in our example today, I'm going to show you a Node.js application which can be accessed externally, right? So in that case, you can use an external option, in which case you can again go to different launch modes as this, right? The launch types are dynamic, which means when you are launching the application, you can go and change these launch types. Because for different purposes, if you're running it on a QA environment, you may want to test it out in a different mode, whereas in case of your production environment, you may have a different setup, right? So you have different launch types. As long as your application template is defined, has a port which has the type as external, then you can choose one of these launch types, right? So in case of a node port, so this is very similar. This is your Kubernetes node port access, where you can access your application using your node IP, and you will use an alternate port to access that application, right? So the requirement, as I said earlier, in this case is to have at least one container must have one external port, right? And in case of ingress without load balancer, so we do not bring a load balancer in this case, but we bring up an Nginx controller. So this may often be a requirement to access your application using a domain name, but your cluster does not have a load balancer support. So what we do is we bring up Nginx, and then we set some alternate ports for 80 and 443. So in this case, you can access using a domain name and over HTTPS as well, and you can access your application. So the requirement in this case, since we are bringing up a ingress router, we need to have some route paths defined in your container. The last option, this is not supported in the community edition though. We have it in our SaaS and enterprise editions, where you can bring up a load balancer. As long as the cluster has the load balancer support, you will be able to set the route paths, and then also access your application using your load balancer IP or the fully qualified domain name, right? So these are the different launch types. Now, okay, so now we have seen the configuration. We have seen how we can access your database, how you can build one layer on top of it, and then access your application also and launch it in different modes. We have to look at how to plan for scaling and updating your stateful applications. All right, this is a very crucial part, because it's not going to be like the day one operation, it's about the day two as well. How do you maintain such database applications, right? So there are a few concepts that we must know before we look at the maintaining the stateful applications on Kubernetes. The first one is called the ordinal value. The ordinal value sets the order in which the replicas for a stateful services are created. Say for instance, here eSearch, Elasticsearch with replicas is a service name, right? And you actually gopaddle brings up pods with specific within a particular service. Now what happens is every time it brings up a new stateful service, it adds Kubernetes adds a postfix to it. So for instance, you have esearch 0, esearch 1, esearch 2. So these 0, 1, 2 are called the ordinal values. It's the order in which these stateful sets are launched. Now this is important for both in terms of scaling as well as for updating, right? So you should make sure that your names or the references within your applications or your scripts always refer to the service name followed by the ordinal. We should avoid using any host names or host IPs, because that way, we are making the application more stringent. So if we are using these DNS names followed by your ordinal value, then it is very dynamic. So I will show you one example within MongoDB script itself, right? So that's a key consideration when you're doing a rolling update, because based on these ordinal values, even Kubernetes is going to do the updates in a sequential order with the largest ordinal value, which means it starts with esearch 2 and then 1 and then 0. So it goes in the reverse order, right? And partition is something that tells you what all replicas have to be updated. So if you have 0, 1, 2, then if you have set the partition value as say 1, it is going to update from that ordinal value, which means from 1 onwards, all the replicas will be updated. So 1 and 2 will get updated, and 0 will not get updated at all, right? Even if they are deleted, next time it is going to bring up the same replica with the same configuration. It is not going to apply the updates, right? So this is the partition. Now coming to persistent volumes during updates, what happens to the data, right? So it's going to bring up a new version of the replica, but it will try to attach to the same persistent volume. So your data will still remain. So no new dynamic volumes are provisioned. So these are some key concepts that we need to know, not just for MongoDB, for any stateful application as such. So if you want to look at more information related to this, we have a help document with more scenarios covered, and how the rolling update works, what considerations you need to make for a stateful or even a stateless application. So you can access this if you search for creating and using deployment policy in our help center, help.gopaddle.io. You will find more information on this. Okay, so let's jump into the demo. So today what we have got, so this is our gopaddle dashboard. We have gone through it in the last few weeks. So today what we are going to do is to show you some of the templates that we have subscribed from the marketplace. So we have two templates for MongoDB. One is distributed, and we also have one for the replication mode. So the shard mode. So we have already subscribed to these. So I have two templates here. So this is the distributed mode. So let's take a look at, this is already subscribed from the marketplace. The way you do that is actually go to, say, let's take, for instance, let's take this Redis, for instance, right? So you can actually go to the template and then subscribe. So it has two services, master and Redis replica. So you can just go take a look at all the licenses, and from where we have adapted this template also. So these are templates that are vetted out, tested. The difference, like you get these templates from other sources also, but the difference is that you will be able to visualize and make modifications to it without even having to write any YAML files, and without worrying whether this will work or not, because most of these are all these templates are tested and onboarded to gopaddle, right? So you have you can go back to this template and then you can subscribe. So this will create a copy of the whole template into your user space user templates, right? So you can see all such templates here, and you can also create your own templates by creating add new templates. So we have seen all of this in the last week. So let's move on and take a look at the MongoDB distributed. So this has a couple of services. So we have brought up two different setup. We have subscribed to the MongoDB distributed, and we have added one more application service to this. So in this scenario, what is going to happen is this. This is a Node.js application. You can take a look at this. So this is a stateless application, and we are going to access. We are going to access the MongoDB service within the same application using its service name, right? So this is a very simple Node.js application. So just the connection string is pre-built into it, and this username, password, and the connection string is being tailored to talk to this particular MongoDB service. So since this is distributed mode, as I said earlier, we don't have any shard services or config service or anything like that. And arbiter is pre-built into it. So you can delete this if you do not want an arbiter. But if you need, you can just retain it. And you have the init. So the init service, the purpose of this init service is to initialize any new replica that comes up. So this, you can take a look at the configuration. It has a init a container with some start script. So what it does is that it looks for the name of the pod. If the pod name is starting with 0, the ordinal value is 0, then it assumes initially as the primary node, right? And after which, if you bring up any other pod, then Kubernetes is going to add an ordinal value automatically. So it will, by default, it will set us as the secondary. So you see the replica set mode is either set to primary or to secondary. So this is automated based on your init script, and you don't have to worry about it. So even if your replicas scale, it will scale seamlessly, right? Now this is the init script. Now let's take a look at the actual MongoDB, right? So it has a couple of environment variables here, and you see the replication mode and the where is it? Yeah. Okay, so the pod name. So let's take a look at the pod name. So the pod name is coming from the kube's metadata.name, right? So this metadata.name is nothing but your service name. And your pod namespace is going to be your metadata.namespace. So this is totally dynamic in the sense you can launch the same template multiple times and set different values for your application name. It's totally dynamic. So it will automatically take your service name accordingly, and your service name is MongoDB headless, right? The initial primary node is the first replica that comes up when you launch it for the first time, and it is by default, it is set to, MongoDB -0. From then on, as and when Cube is going to bring up a new replica, it is going to bring up with its own ordinal value. Okay, so it's just this. So as I said that in case of a distributed mode, let's go back and review what environment variable we have to set. All we have to do is to switch between primary and secondary based on the ordinal values. And that is taken care of through the init script. Now let's go to the next configuration, which is your, so we will see an application. I'm going to show some rolling updates and, the scalability with respect to this. And we also have one more template, which is for the sharded mode. And you can see you have 3 different services like I discussed earlier. So Mongo S is the external facing service. And in this case, if you want to access the application, you have to access it using the Mongo S endpoint, right? Not the shard endpoint. So you have to open up the firewall ports for that particular application and then access it. And if you look at the MongoS service again, you can see the environment variables. These are the key because all the modes are set based on the environment variable. So if you can see, the sharding mode is set to MongoS, right? Other sharding modes are available. So you can take a look at this. So sharding mode can be config server or shard server or MongoS. So right now what we have is MongoS. and its host name is MongoS. And if you want to bring up additional replicas, you can do so as well by changing the replication mode, right? So let's take a look at the shard here. The shard has environment variables too. The shard mode is shard server, and the shard's advertised host name is primary. So now this does not have an init, so we may have to tweak this a little bit, right? So the replica set name is hard coded. So this is the key difference, right? So you have seen how the other template is very dynamic, whereas this is more or less you have to manually go add services with specific names. And similarly for config server, you have the replication sharding mode as config server. Okay, now let's go back to the application. So we have launched these templates. At the time of launch, we have to choose a couple of options based on how your external ports are configured. So let's try launching this. I'm not going to really launch, but I'll show you the options. So when I launch, I can provide an application name, and then you have to, so when you subscribe, it has actually created a separate release for each one of these, and then you will find different images being pulled automatically, and then you can choose the provider, right? So in this case, since I'm showing, I have a GKE environment, I have the default provider type as Google, but you, in case of your local environment, this is going to be microcatus. So you need to choose the provider type as microcatus, and then you can, if since we have a data volume, we have to use the data volume, persistent volumes. Now if you are using a host volume, like in case of microcatus community edition, we only have the host volume support, so in which case you have to choose the cluster provided storage driver, right? And then this will take the default storage class, which is nothing but the host path in case of microcatus. And then you can use ingress, or you can do a node port, just a port mapping. Now the reason why this is showing the Mon Social 3000 is because it has an external port, and it also has a route path, which I'll show you in a minute, right? So you can either choose ingress, and then choose whether you want to launch it with a load balancer or without load balancer. In case of our community edition, you will not have this ingress with load balancer option, and otherwise, you will have both the options. You can see if you are going with the alternate port, so you can choose one of the port ranges, and then you can move on, right? So these are different environment variables which you can actually go and edit. So for the database, you can find all your root passwords and other information from the template itself, but if you want to change anything, you can go change it here. So next comes your config maps. Now there is a config map which I showed you for the init container, and it is mounted on the /init path. Now if you want to change this config map, you can edit this and then change it as well. So you can change the config maps and its corresponding versions if you have multiple versions. Otherwise, like, you can just skip this and move on to the next one. So if you are, another best practice is, whenever you are launching your stateful applications, it's better to set the the pod affinities and the node selectors appropriately, because when the even the cluster scales, Cube will try to schedule these stateful services on the right nodes, but if there is some node problem, then it may lead to other challenges. So it's always better to have some sort of a node labeling, and position your stateful services based on, or schedule your stateful services based on the node selectors. So in this section, what you see is what is the service that you want to apply these rules, and the node selector rules, and then you can see all the different types of labels that are available in this different nodes. Now you can change these labels. I'll show you the section where you can go and change these or add these node labels, but you can select a service and then select a value that you want to set. Say for instance, if you want to provision this MongoDB service on this particular zone, you can select this, and then you can select multiple such rules as well. And then the last step would be to add any affinity rules. So what you saw are node selectors, and these are affinity rules, and you can select different types of affinity rules here. So you can set affinity or even anti-affinity. So if you don't want to provision certain pods on a specific nodes, say for instance, you don't want your MongoDB service and your Node.js service mixed up. So you may want to say anti-affinity, saying, I don't want to provision Node.js on this particular when where MongoDB is being provisioned. So you can set certain kinds of rules and select the service where you want to apply that, and you can set these anti-affinity rules as well. So if you actually go to our help documents on how to set the affinity and anti-affinity rules, there is a separate section dedicated for this, and you will find a lot of information on how to go about setting these affinity anti-affinity rules. All right. Yeah, and then the final step would be to launch, and that's how we actually brought up this application that is running now. So let me show you the MongoDB distributed mode now. So what I'm going to do now is to show you how the scaling works first, right? So let's take this MongoDB. So Arbiter is running constantly, and we have MongoDB with 2 replicas already. So we have 2 replicas, 0 and 1. So 0 is what we created, and based on how our deployment policy is being set, Cube is going to bring up additional replicas. So by default, the replication is set to 2. So Cube has brought up one more replica. So this 0 is brought by our initial host name settings, and the second one is based on the service name followed by an ordinal value. Right now, you can review these policies under policy section. Under deployment, you see that the replicas is set to 2. So this is the default deployment policy that is applied. Right, that's a part of the template itself. Now, if you want to increase this count, you can increase the number of replicas, right? And you can also update the partition. So the partition here says anything that is above this ordinal value will be updated. The rest of it will not be updated. So I'm going to set this to 1, right? So which means this is going to bring up one more replica. So we'll ultimately have replica 0, 1, and 2. And if I apply any updates, then only replica 1 and 2 will get updated. So I have applied the policy. Let's wait for a couple of minutes for the other replicas to come up. So we can see that automatically, Cube has provisioned one more replica, which is MongoDB 2, right? Now let's get started. Now what is happening here is that it's going to run 2 containers. One is the init container. Still, it has not provisioned, so it's still waiting for a few minutes.
Yeah, insufficient CPU. Let me increase the the capacity.
I'm sorry.
Uh, it's showing like a part of unbound immediate. Oh, okay. Yeah, it will take some time. Yeah, I
Yeah.
thought memory issue.
Okay, no problem. So this will take a couple of seconds. So let's wait for another replica to come up, and I'll show you with the existing replica itself what has happened, right? So the service is started. It's trying to bring up the containers now. Let me see if it is still, yeah. So you can see that the init container has completed. So it has, based on the ordinal value, it has decided whether it is primary or a secondary node. So we can even see, go back to the terminal, and then print the environment variables to see what value has been set. Right, so let me print the values. Right, so here you see all the environment variables within the container is listed, and
I think at the bottom it's saying the pod name.
okay, let's see that. So here you can say the headless service name, and its host name is automatically set because we have used the Cube metadata for setting the environment variable. So all these values are automatically picked up from the Kubernetes environment. So it's totally dynamic, right? And let's take a look at the environment variable for the replication mode, and see the initial primary host is still 0. So the primary server from where you have to replicate the data. So this is going to be more or less, initially when it comes up, it is pre-configured, but this can actually, this name will remain the same. If there is a primary node going down, then Cube will automatically pick the names accordingly, right? I'm not seeing this replication mode. So Gayatri, are you able to see it?
Yes, exactly.
Let me see. Okay, so looks like it has automatically picked up in the this environment variable is not.
It is host name only, I think.
I'm sorry. It's just the
It's
host name.
host name, yeah.
Yeah, it's only the host name, so it is not really setting the mode. But I think you still will have this variable which says whether it is a sharding mode or not, right? So the because the init script is the only one which is making use of it for the host. I mean the host name, but you should have the sharding exposed. Right. Okay, so looks like it's not being set. We'll come back to this. So Gayatri, in the meantime, can take a look at this, right? So this has brought up the replicas. We have seen how the scaling works. Now let's move on and see how the ordinal value comes into picture and how the update happens for the stateful applications. So let's go to the service artifacts, and then we will go back and update the do some revision changes, right? So I have no revisions as of now, and I'm going to update this image and change it to version 443. And this is going to perform a rolling update. And since we have set the ordinal value to 1, it will update 1 and 2, right? Okay, so now this is going to create a new revision for us, and you will see these changes coming up in the revision history in a short while. Okay, so let's go to the application logs, and we will see whether this rolling update is happening. Okay, so we have updated and it is going to scale down, and again scale up. So let's go to the services, and we'll see the replicas here. So it is first updating MongoDB 2, and then it will update 1, and it is not going to touch MongoDB 0. Right, so now this has started a few seconds ago. Now it is updating a Mongo 1, and it will stop with this. So, this is how, all your DB updates happen. And if you also want to take a look at the different, volumes that are created, you can see all those volumes, their metrics, and all those kind of, information here. So since this is a, you see the replica for this volume is attached to replica 0, and you can also see for this is for replica 1 and for replica 0. So you will be able to find out which volume is attached to which replica, and what is the directory on which it is mounted, and any such logs that may be there, right? So this, I think, overall covers how you can run MongoDB, how do you how do you provision your applications, and how to access. So let's see how to access. I think I missed that part, right? So I have shown you in case of the distributed mode, like you had MongoDB service, and you had the Node.js service also. So the Node.js service in the start script, it was referring to the connection string where we just use the service name. Another approach is to use the headless service, and I'll show you in the template on how to use that. So we have a separate MongoDB application, the same Node.js application, however, which is trying to connect to the sharded mode with a different connection string. right? So here, okay, so I think,
You can directly show in the application.
yeah, so I think we have edited directly in the application. So we have this merge social here, and we have set this start script to point to um, the headless service. So you can see here, you can give Mongo S headless, and this is the sharded name service or the application name, followed by service cluster local and the port number, right? And this username password, you can get it from your templates environment variables. And this is how, this is an alternate approach in which you can connect to MongoDB. If you don't want to create the whole stack in a single template, and if you want to keep your MongoDB as a separate template, you can do this as well. And I think that this brings us, okay, let's go back to the application one last time, and we'll see whether the MongoDB has updated the replicas, and we want to just check whether it has left Mongo 0 untouched. Right, you see it has started an hour ago, which means it has not been updated, whereas these two are updated, right? So I think this covers the overall setup and how you can scale, you can deploy, scale, update your MongoDB services in both replication and in the sharded mode. I hope you enjoyed this video and found this useful. If you did, please share this video and give us a thumbs up, and that will be a great motivation for us. Thank you all. Have a good day.